Welcome to Best Academic TV. In this video, we're gonna focus on Uniport post repeated questions on electricity. Let's solve one of the questions here. They said a resistor 10 ohms is connected to a 20-volt battery. Calculate the current flowing through the resistor. All right, we are giving resistor to be 10 ohms and we are giving volts to be 20 volts. The formula that connects resistor voltage and and current, the formula that connects resistor voltage and current is Ohm's law. So the formula for Ohm's law is this, that is V is equal to I R. So let's replace what is given to us here and make current the subject. Volt is given to us as 20 is equal to current is what you're looking for. Resistor is given to us as 10. So class, making I the subject of formula, I will be equal to divide both sides by what's attached to I, which is 10. This will be equal to class 20 divided by 10. And the answer here, I, will be equal to 2 amps. Please take note of this. So this is the answer here. So the next question here, we're asked to find power. They said an electric bulb operates at 220 volts and draws a current of 2 amp. Calculate its power. The formula for power here, relating to volts and current, is power is equal to plus IV. So let's replace. Current is 2 times the voltage is 220. When you multiply this, we have this to be 440 in watts. Most times you'll be asked to convert to kilowatts. You divide by 1000. So I'm going to have this to be 0.44 kilowatts. Please take note of this. Whenever you're asked to convert anything in kilo, you divide the result by 1000. Okay, now let's solve the next question here. The next question here, we are asked to find the equivalent resistance. It can either be called equivalent resistance, or you can call it total resistance or effective resistance. Please take note. So we are given 3 resistors in series, that is 2 ohms, 3 ohms, 5 ohms. So whenever you're asked to find the equivalent or the total resistance in series, that is the total resistance or equivalent or effective resistance in series, is equal to I1, that is the first one, plus I2 plus I3, depending on what is given to you here. Please take note, IN. So let's replace this here. Arrow 1 plus arrow 2 plus arrow 3 dot plus arrow n. So depending on the amount of or the number of resistance given to you there. So arrow 1 is given to us as 2 plus arrow 2 is given to us as 3 plus arrow 3 is given to us as 5. When you add up together, it will be equal to 10 ohms. Please take note. This is my answer. So the next question here, they said 2 resistors of 4 ohms and 6 ohms are connected in parallel. Calculate the equivalent resistance. So the equivalent resistance for parallel resistor is given to us as the equivalent, or the total is given to us as 1 over arrow equivalent is equal to 1 over arrow 1 plus 1 over R root 2, depending on the amount given to us there. So we have to replace our RO1 here. The RO1 here is the first resistor. The next, we have to replace our RO2 here, which is the second resistor. And after then, we make RO equivalent the subject of formula here. And we also have short way to solve. Remember that you only given 30 minutes to answer 30 minutes to answer 15 questions. So you have to be fast. Replacing the value here, class, we have this to be 1 over arrow equivalent is equal to 1 over arrow 1 here is 4 plus 1 over arrow 2 here is 6. So I will solve the fraction here, this fraction here, and whenever we have two fractions, to solve that we look for LCM. Please take note. But there's a shortcut here called butterfly method. That means this denominator at your right hand side will multiply the opposite. This denominator at your left hand side will multiply the opposite, while both denominator will multiply itself. That is this. We call it butterfly method. It means this multiply with this multiply with this, and this multiply with this. Is called butterfly method. Okay, so very simple. Our 1 over arrow equivalent will be equal to, if you apply that law, to be 6 plus, the plus is the sign at the middle, 4 over 24. So I will have this to be 10 over 24. We're not asked to find 1 over arrow equivalent. We are asked to find arrow equivalent. So making arrow equivalent, I will invert this left hand side to get arrow equivalent. And in the law of equation, whatever you apply at the left hand side is the same you apply at the right hand side. So you also invert the right hand side. Please take. So when you do that here, it means that arrow equivalent will be equal to class 24 over 10, and the answer is 2.4 ohms. The shortcut here to solve parallel resistance, the shortcut here to solve parallel resistors is this: arrow equivalent is equal to the product of the resistors over the sum of the resistors. Let's solve this here. We only use this particular formula here if the resistors are 2 only. Please take note of this. If the resistors are 2, we use this particular formula. But if it's more than 2, please, we don't use this formula. We use the previous formula to solve, the previous method to solve. Please take note by looking for the LCM. Okay, so class, I will have this to be the sum of the two, the product of the two resistors. So it's 4 times 6, 4 times 6, while the sum of the two resistors is 4 plus 6. So I will have this in class 24 over 10, which is the same as 2.4 ohms. Please take note of this. Okay, let's solve the next question here. That is question 5 under questions on electricity. The next question, question 5 said a 1000 watt electric heater is used for 3 hours. Calculate the energy consumed. Either energy, electrical energy, or electrical work done. Please take note, they are the same. If you're asked to calculate the energy consumed or the electrical work done consumed, is the same. Please take note. So the energy consumed when power is given and the time is given, we have this to be power from the formula for power. That power is equal to work done. Please take note, work done over time. The formula relating power work done and time is power is equal to work done over time. Now making work done the subject of formula here, class. Work done, and this work done is electrical work done is equal to power times time, which should be equal to class, to be equal to, let's replace the value for power is 1000 times the value for time taken is 3 hours. Converting that to seconds, we multiply by 3600. So this will be 3 times 3600 in seconds. Okay. So class, this will be equal to class. When you punch your calculator, I will have this to be 108 0 0 0 0 0. That's 1 2 3 4 5 6. I guess so. Okay, in watts. You can also convert this to kilowatts, please. You can do that and write it on the comment section. Converting this to kilowatts, what will be the answer? If I'm converting this to kilowatts, what is going to be the answer? Okay. Now the next here, we are asked to determine the total EMF in series. The total EMF in series is to add up the EMF. So the total EMF here, that is total EMF in series,